function is continuous, it is differentiable.
You might not be able to take the derivative, but
Maybe a picture. Why is number 1 false?
you might not be able to take the derivative of it.
Is that continuous? Absolute value function, is that continuous? Is it differentiable at 0?
No.
So because it has a sharp corner, right? So being continuous does not guarantee that you have a differentiable function.
What time are you again?
It's differentiable. You can take the derivative, and remember the derivative is that limit of the slope thing. So this one, the slope on the left is -1, and the slope on the right.
Differentiable is if it's different.
The places that it's not differentiable are at sharp corners, cusps, vertical tangents, and discontinuities. Now, that being said, if a function is differentiable, does that mean it's continuous? Yes, because you have to be continuous to be differentiable. So just to look at that. Okay, given f of x as shown in a figure, at which point is the function continuous but not differentiable? D, I would agree. D, yeah. Oh, well, D might be a little smoother. I agree, it kind of looks sharp. B definitely looks like a sharp corner. Everyone agree? B is a sharp corner. I think on D, the point makes it look not smooth, but I think it is smooth. That is a little tricky.
That's always going to be at like 0.
No, it could be anywhere.
It's just like it goes to a point.
We can horizontally shift that function to the right or left. Okay, you need to know this. We said it in the bell ringer, but you need to write it down. It's important. Differentiability implies continuity. If a function is in our notes. Okay. If a function is differentiable at a point, it has to be continuous at that point. Differentiability implies continuity. As you saw in the bell ringer, that the converse of this statement is not true. You can't switch it around and it still be true.
Okay, this is really hard to do, like, when you know a bunch of stuff. Like, taking the derivative of tangent. Like, I know what it is.
On the homework, the pot stuff. Are we gonna learn that today? Yeah, deal with that.
No, it can ask, but I'm finished. I think you probably know how to do it. You probably do it circle stuff. But you probably know how to do it somewhere. Great. Okay. So I want to do this example. This should help a little bit with the average rate of change question, although it won't help with the tricky part of the average rate of change question that you'll have with what to do on it. Suppose f of x equals x squared minus 2x plus 1. Find the secant line slope on the interval 1 to 4. Does the secant line slope have anything to do with calculus? No, why not? Yeah, you learned that in Billingsley. The secant line slope is just the slope from here to here. rate of change. When you hear that question, think pre-cal, algebra 1, right? It's just a slope. If they asked you that on your homework last night, they asked you to find the average rate of change between 2 points. Well, how do you do it? You're going to do f of 4 minus f of 1 over 4 minus 1. That's a fancy way of writing y2 minus y1 over x2 minus x1. Remember, f of 4 is the y value when x is 4. And so what is the y value when x is 4? I will find out by plugging in 4 into the function. 16 minus 8 plus 1 is 9, I think. 1 minus 2 is 0. 9 divided by 3 is 3. So the average rate of change, or the slope between those 2 points, is 3. So when it asks for the average rate of change or the slope of this secant line, that's how you do it. Find the equation of the derivative. Does that involve calculus? Yes. I'm going to use the limit as h approaches 0 of f of x plus h minus f of x all over h. Question? Come on. I don't want to be this question. X squared what? Oh, you're thinking for tomorrow? Trying to figure out the rule? I'll answer rule questions tomorrow. Today you just got to do it. But if you're noticing some patterns, aren't you? Keep noticing. I'll answer tomorrow. Believe me, I'm ready for you to look for it. As long as you don't know the rule, that's story this way too. But gotta understand the rule. Gotta spend a couple days on this. I can factor out an h up top. It also makes you appreciate the rule. Doing it the long way. Good so far? H is canceled, the limit is h approaches 0, let it be 2x minus 2. Any questions?
I am just still kind of confused about x and answer on this original.
Good question. So let's look at the original function. Does the original function have the same slope all the way around it?
No.
So your slope is going to have x's in it because it's going to change. Now, if your original function is a line, any kind of line, horizontal line,
So if it's
that's
just a line, like it doesn't have anything with rules in it or anything,
that's the only time your answer will just be a number. And you could probably guess what that number would be.
because it has it in there.
It's slope, right? So it's, we did one yesterday, like negative 8. Yes, negative 8. And we did a horizontal line, y equals 7. Let's go to that 0 because the slope of a horizontal line is 0.
The one that's like that, if it ever gets a case where it's not that close number, it's like not -8, like it's like.
Not if it's in x plus b. Now, if they rearrange it or something, if it's not. But if it's a line, the slope is the slope, no matter whether you do that using calculus or algebra. In fact, it almost feels silly to find the slope using calculus because you know how to find the slope. And most of the time, actually all the time, when you come to a line, you'll say the slope is, if they ask for the derivative, you'll just tell them the slope. You won't do any kind of long work to get that because you know the slope. Find the tangent line slope at x equals 3. Well, what is the slope of the tangent line? What's another word for that? The derivative. I know the derivative, right? So I just want the derivative at 3. And so this kind of brings up Kelsey's question. Okay, this slope changes as we move along the function. I want to know the slope when x is 3. Which is 4. So the slope of the tangent line is 4. Once you have the derivative. One other piece of information, and it's something I don't want you to take lightly, it's actually very, very important. There are two alternate definitions of the derivative. AP will use all three of them in their problems. I will show you later this chapter how AP will actually ask you definition of derivative questions. They do ask you those questions. They never make you actually work out the whole derivative. But they want you to recognize that it is a derivative. Well, there are three definitions of derivative they will use, and they will use them interchangeably. So you need to be aware of them. It doesn't matter which one you use. If you were to have to do a definition of derivative, you could use any of the three. The one that I like the best is the one that you've seen up until this point. I think the H is nice and clean, easy to cancel, a little easier to work with. But all three of these are perfectly fine definitions of a derivative. The first one is really easy for you to understand because what's the only difference in the one that you have memorized and that one? They use delta x instead of h. Does it make sense to use delta x? We learned yesterday that h was the change in x, so it makes sense to use delta x. Again, the reason I don't like to use it is because when you're working it out, it gets kind of clunky when you're canceling out delta x's. You might accidentally think it was a regular x. So that's the only reason I don't use it. It's a perfectly good definition. You may see that on the AP exam. Just in your brain, change delta x to h, and you're good to go. The bottom one looks completely different. It is the definition of derivative at a specific point. It will not give you a function with x is in it. It would give you a function with a is in it if you worked it with an a instead of x. But normally when you use that second one, you're trying to go straight to finding the derivative at a point, like at 3.
So that's like on A.
Sort of. Not quite, because it still has a limit. But you see how we wanted the slope as x approaches at 3? We could have used this bottom definition. I'll show you how it works. F prime of 3 would be the limit as x approaches 3 of f of x minus f of 3 over x minus 3. Yeah, I mean, it does the exact same thing. It's not any longer if you've already done the work. So let me show you how it works. What was f of x squared? And f of 3, what is f of 3? 9 minus 6, 4. So you said. Which gives me that. But remember, when we did the other way, we did that whole limitization to 0 before we started. I would argue almost equivalent in how long it takes, but this only gives you 4. Is that what we got on the list? Let's go.
If that isn't what's tried to A, what was the
A was just this. Didn't have a limit in front. Oh, it's just
or is it Y minus?
y2 minus y1 over x2 minus x1.
But since it was like the just 1 and 4, you just put the what if it had like 2 different?
You would plug whatever it was in. That's like your homework. You'll plug in the pi over 2 and the 11 pi over 6. Whatever it is. Okay. Any questions about this? I'm going to give you another homework assignment, and I'm going to give you time to work in class. You've got 30 minutes left in class, so you have that homework assignment, and then you'll have another one that I'll hand out. If you have any questions, let me know. I heard some of you say you did, so just ask me if you have questions on the homework.